In this video, we want to learn about factoring trinomials. The first example is x to the 2 plus 7x plus 12. This is a trinomial because we have three terms, x to the 2, 7x, and 12. These are the three terms of this trinomial. For factoring trinomials, when the variable is x, we put two brackets, and in each bracket first we put x. And attention, here we start with trinomials that the leading coefficient, the coefficient of x to the 2 is 1, like these two examples. Then we work on examples that the coefficient of x to the 2 is other than 1, like 2, negative 3, 5, and so on. First we start with the easy case, which is the leading coefficient is 1. So we put two brackets, and in each bracket we put x. The reason that we put x is that when we multiply these two brackets, x times x is x to the 2. Now we look for two numbers, so here we want to put two numbers here and here, such that 12 is the product, is the multiplication of those numbers, and 7, so this is the product of the numbers, and 7 is the sum of those numbers. So we want to put two numbers here, one in each bracket, such that the product of those numbers is 12 and the sum of them is 7. If we look for numbers that their product is 12, 12 can be written as 1 times 12. It can be written as 2 times 6, 3 times 4. And of course, you can write it as negative times negative 12, negative 2 times negative 6, negative 3 times negative 4. But between these pairs of numbers, we are looking for the one that the sum is 7. 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. So between these pairs here, this is the numbers that we are looking for. And so in the first bracket we put 3, and in the other bracket we put 4. The order doesn't matter. You can put 4 in the first bracket, 3 in the other bracket. But what is the reason that we use this technique? Why this technique works? Let me tell you the reason behind this technique. We expect that when we multiply these two brackets, we get back to this trinomial. When you multiply these two brackets, what happens? You multiply 3 by 4. It would give you 12. So 12 is the product of these numbers. So this is the reason that the 12, the number, the constant of the trinomial, always is the product of these numbers. But why 7 should be the sum? Because when you multiply these two brackets by each other, you multiply first x by x, then you get x to the 2. Then you multiply x by 4, so you have 4x, and of course you are going to multiply 3 by x, 3x, so you have 4x and 3x. And because they are similar terms, 4x plus 3x, so you have 4x and 3x. So you add these. So you add these to each other. So the sum of these numbers should give you 7. So that's the reason behind this technique. So always we look for two numbers that the product of those numbers is the constant, is the 12 in this case, and the sum of those numbers is coefficient of x, which in this case is 7. Now let's try the next example. We want to factor this. We put two brackets, x in each bracket. Then we are looking for two numbers that the product is 15 and the sum is negative 8. Because the sum is negative 8, so this means that the numbers that we are looking for are negative. Because the sum is negative, so the numbers are negative. The product is positive. If we multiply two negative numbers by each other, their product is positive. So what numbers multiplied by each other can give you 15? Negative 1 times negative 15 is one choice. Negative 3 times negative 5 is another choice. Negative 1 plus negative 15 is not negative 8. So this is not the answer. But negative 3 plus negative 5 is exactly negative 8. So these are the numbers that we are looking for. The first bracket is x minus 3, the other bracket is x minus 5. So we can factor this trinomial in the form of x minus 3 times x minus 5. Now look at these two examples. X to the 2 minus 2x minus 8 and 2x to the 2 minus 2x minus 40. In the first example, we are looking for two numbers that their product is negative 8 and their sum is negative 2. Because the product is negative, so it means that one of the numbers that we are looking should be negative, the other one is positive. Because negative times positive, negative times plus is negative. So this is important and it helps you to find the numbers easier. One number negative, the other one positive. And the sum should be negative 2. Two numbers that their product is negative 8. The numbers can be negative 1 times 8 or 1 times negative 8. None of these works because the sum of these pairs is not negative 2. The other case is negative 2 times 4 or maybe negative 4 times 2. Between these two, which one the sum is negative 2? Negative 2 plus 4 is 2, but we need negative 2. So no, this is not the answer. But negative 4 plus 2 is exactly negative 2. So the numbers that we are looking for in this example is negative 4 and 2. So we can factor this and write this in the form of x minus 4, x plus 2. And again, the order of writing these brackets is not important. You can write x plus 2 first, then x minus 4. Because in multiplication, the order of the expressions is not important. Look at the next example. Here we face an example that the coefficient of x to the 2 is not 1, it's 2. But remember, always, when you want to factor an expression, always, without exception, the first thing that you have to check is to check for common factor, greatest common factor. You should not start thinking, okay, this is a trinomial, I have to factor it as a trinomial. No. Whenever you see any expression, first you look for common factor. Is there any common factor between these three terms here? 2x to the 2, 2x and 40. Or 2x to the 2, negative 2x, negative 40. Immediately we notice that 2 is the common factor between these numbers. So first, before doing anything, we factor 2. Then, by factoring 2, we have x to the 2 minus x minus 20. When you factor the common factor, basically you are dividing every term by that. 2x to the 2 divided by 2 is x2. 2x divided by 2 is x. 40 divided by 2 is 20. Now, inside the bracket, we have a trinomial, and coefficient of x to the 2 is 1. And we know how to factor trinomials like this. We are looking for two numbers that their product is negative 20 and their sum is negative 1. Coefficient of x is negative 1. So we look for two numbers that their product is negative 20, their sum is negative 1. Because the product is negative, one of the numbers is negative, the other one is positive. We can think to negative 1 times 20 or negative 20 times 1. But this is not the answer. Negative 2 times 10? No. 2 times negative 10? No, because the sum is not negative 1. What about 4 times negative 5 or negative 4 times 5? If you pay attention, 4 plus negative 5, 4 plus negative 5 is negative 1. So the numbers that we are looking for are 4 and negative 1. So we can factor this and write this as, don't forget you have a 2 outside, 2 bracket, x plus 4, x minus 5. So this is the factored form of this trinomial. Now look at these examples. Negative x to the 2 plus 99x plus 100. In this first example here, the leading coefficient is -1, and we hate negatives. So what we have to do first? We can factor a negative from this expression. We prefer always the leading coefficient to be positive. But here we have negative x to the 2. We prefer to have x to the 2, not negative x to the 2. So we factor negative first to make our expression a little better. So we factor a negative, then we have x to the 2 minus 99x minus 100. We change the sign of every single term. Negative x2, x2. 99x, negative 99x. 100, negative 100. If you multiply negative in the bracket, you get same expression. Now, inside the bracket, we have a trinomial, a normal trinomial. Leading coefficient, the coefficient of x to the 2 is 1, and we know how to factor this. We are looking for two numbers that their product is negative 100, so one number positive, the other number negative. The sum is negative 99. So we are looking for two numbers that their product is negative 100, their sum is negative 99. We start with 1 and negative 100, or maybe negative 1 times 100. Between these two pairs, which one satisfies this condition? The sum negative 99. Sum of these two numbers is exactly negative 99. So we can factor this as negative 2 bracket, x in each bracket. The numbers that we are looking for are 1, so plus 1, and minus 100. This is the factored form of this given trinomial here. Look at the next example. X to the 3 plus 2x to the 2 minus 80x. This is a trinomial, but its degree is 3. X is x to the 3. We notice that we have a common factor, x. So we first factor x. Let me repeat this here. When you look at any expression, when you want to factor, first check for common factor before thinking to any method. Factor common factor first. Here, x is the common factor. If we factor x from these terms, then we have x to the 2 plus 2x minus 80. When you factor a common factor, basically you are dividing every single term by that term. X to the 3 over x is x to the 2. 2x to the 2 divided by x is 2x. 80x divided by x, x with x cancels, and negative 80 basically remains. So we factor x, then we have a normal trinomial in the bracket, x to the 2 plus 2x minus 8. Now we have to look for two numbers that their product is negative 80. So we look for two numbers that their product is negative 80. And the sum is 2. Those numbers can be negative 180 or negative 81. But none of these works because the sum is 2. What about negative 2 and 40? Or maybe negative 40 times 2? No, this doesn't work. What about 4? Negative 4 times 20. Or negative 20 times 4? No, this also doesn't work. What about negative 8 times 10? Or negative 10 times 8? Check this. Negative 8 plus 10 is 2. So this is the pair of numbers that we are looking for. 2 bracket as usual, x in each bracket. 1 bracket minus 8, the other one plus 10. And this is the factored form of this expression here. Now look at these two examples. X plus 5 to the 2 minus 10 times x plus 5 plus 24. Here, the thing that we notice is that we have a bracket x plus 5, and this bracket is repeated, x plus 5, x plus 5. This is like a trinomial. If you pay attention, for a moment, consider these as a box. So we have a box to the 2 minus 10 box plus 24. So this is like x to the 2 minus 10x plus 24. So this is similar to the trinomial. If we name this bracket A for ourselves, because when we look at this bracket, this is a little confusing. If we suppose this bracket A, this expression is like A to the 2 minus 10A plus 24. Now focus on this. Forget this which we had in the beginning. Focus on this, please. Only focus here. Now, this is a normal trinomial. This is like x to the 2 and the leading coefficient is 1. We know how to factor this. But please pay attention, you have to put in each bracket a, because the variable is not x, the variable is a, so we put a in each bracket. Now we look for two numbers that their product is 24 and their sum is negative 10. What are the numbers that their product is 24? Their sum is negative 10. Two numbers that their product is 24 and their sum is negative 10. Those numbers are negative 4 and negative 6. You can try different pairs and you can find those numbers. Negative 4 times negative 6 is 24. Negative 4 plus negative 6 is negative 10. So the numbers that we are looking for are negative 4, negative 6. So now we know the factor form of this. But this was not the question. The question was this. Now we do the opposite. Now we remember that this A is actually x plus 5. We name this A to make the question for ourselves easier. When we look at this is so confusing. But when we name it A, this is something familiar. Now, we substitute back. We remember from the past that A was actually x plus 5. So, now we substitute A with x plus 5 because A is x plus 5. So we replace this A here with x plus 5. And don't forget you have a negative 4. And then A again is x plus 5. Whenever we say A, you have to remember A is x plus 5 minus 6. Then in each bracket, we simplify the expression. X plus 5 minus 4 is x plus 1. X plus 5 minus 6 is x minus 1. 5 minus 6 is minus 1. So the technique is that when an expression is repeated and you don't like that big expression, name it something and make your expression simpler for yourself. At the end, you can substitute back. Look at the next example. Again, we can see something similar to the previous question here. We notice that this expression here is repeated. So you can name it whatever you want. You can name it A, B, C, or anything. You can name it box. It's up to you. I prefer to choose again A as the name of these expressions. Because they are the same, both of them are A. So we have basically A to the 2 minus 5A minus 14. Now we have to guess two numbers that their product is negative 14, their sum is negative 5. What are the numbers? The numbers are negative 7 plus 2 or plus 2 minus 7. Now remember what was A. A is actually 2x plus 3. So we substitute back 2x plus 3 minus 7, 2x plus 3 plus 2. Let's simplify the inside of the brackets. If we simplify inside the brackets, we have 2x, 3 minus 7 is minus 4, 3 plus 2 is plus 5. This is the answer of the question. But you can do something here, which is a good idea to do. When you look at this bracket, you notice that you have a common factor. Between 2x plus 5, we don't have any common factor. But when we look at this, we have a common factor between 2x and 4. What is that common factor? Yes, 2. So you can factor a 2 and put it outside of the bracket. So we can write this answer in the form of 2 times by x minus 2. So from here we factor 2, we put it outside. 2x divided by 2 is x, 4 divided by 2 is 2. And 2x plus 5 remains the same, 2x plus 5. This is the factored form of this expression here. Look at this example, 2x to the 2 plus 3x minus 5. Here we notice that we have a trinomial that the leading coefficient is not 1. And attention, we cannot factor that 2 because we don't have any common factor between 2, 3 and negative 5. So this is an example of a trinomial that the leading coefficient is not 1. So far we worked on examples that the leading coefficient is 1. But here we have an example that the leading coefficient is not 1. For trinomials like this, you can find different methods for factoring trinomials that the leading coefficient is not 1. I highly recommend you to learn one of those methods only and always use that same method. Don't change from one method to another method and change your methods. In this way you confuse yourself. Learn please one method and always use that method. Here I want to use the grouping method. What is the method? Let us start. Here always the method I want to show you in this video is always we multiply this leading coefficient by this number. 2 times negative 5 is negative 10. So always we multiply whatever is here by this. So we always multiply leading coefficient by the constant term. 2 times negative 5 is negative 10. Now, similar to the previous method, we look for two numbers that their product is negative 10. Their sum is 3. Two numbers that their product is negative 10 and their sum is 3. Those numbers are 5 and negative 2. 5 times negative 2 is negative 10. 5 plus negative 2 is 3. So these are the numbers. But don't think that we are going to put two brackets and that's it. No. The reason that we do this here is a little different. Now with these two numbers we want to do something. We want to split this middle term. This middle term is 3x. We want to write this middle term in the form of 5x. We got 5 here. So 3x can be written as 5x minus 2x. Let me write down this here for you. 3x. So in this technique, always we write this middle term in terms of these two numbers. 3x can be written as 5x plus negative 2x or minus 2x. So this is the technique that we want to use in this video. Let me mention this again. In different textbooks, you can find several methods for factoring trinomials that the leading coefficient is not 1. But this method that I am going to show you in this video is probably the best method because it's based on the grouping method. So we write the middle term in the form of 5x minus 2x. Let's review the process up to here. First we multiply this number by this number. We get a new number. Then we look for two numbers that their product is negative 10, their sum is 3. Those numbers are 5 and negative 2. Then we write the middle term, 3x, as 5x minus 2x. Now let me start doing this question. So now we write this as 2x to the 2 plus 5x minus 2x minus 5. Please pay attention. Maybe you wonder why you put 5x first, then negative 2x. You can write negative 2x here, 5x after. The order doesn't matter. The answer at the end would be the same. Now, we do a grouping here. We consider these two as a group, and we consider these two terms as a group. The reason behind that is that we want to factor something from these groups. In the first group, focus on the first group, 2x to the 2 plus 5x. What is common factor? The common factor between these two terms is x. Then we have 2x plus 5. From the next two terms, look at this. Is there any common factor between negative 2x and negative 5? Maybe you think no, there is not. But there is a negative you can factor, which is a good idea to factor. So we look at negative 2x and negative 5. There is basically nothing to factor. Only we can factor a negative, which is definitely a good idea to get rid of these negatives that we have here. So if we factor a negative, then we have 2x plus 5. Now look at these two terms. 2x plus 5, 2x plus 5 repeated. So in this term we have 2x plus 5. In the next term also we have 2x plus 5. So now we factor this common factor. So now we write, let me continue my solution from here, 2x plus 5 times by, from this term, if we factor this, what remains? X. If we factor this from the second term, a negative 1 remains. And this is the factored form of that trinomial in the beginning. So the process is this. We multiply this number by this number. Then we get a new number. Then we look for two numbers that their product is this new number, their sum is 3. We got these numbers. Then we write this middle term in the form of 5x minus 2x or minus 2x plus 5x. The order again doesn't matter. At the end the answer would be definitely the same. Then we make two groups. These two a group, the next two terms another group. We factor common terms and then we get to here. Let me show you why the order of writing these two doesn't matter. Let's say in your solution you are writing 2x to the 2 minus 2x, then you put 5x minus 5. Then look at these two. What is common factor between them? 2x. And if you factor 2x, then you have x minus 1. Look at these two. Is there any common factor between them? Yes, it is 5. If you factor 5, what remains? X minus 1. Now, x minus 1 is common. We factor x minus 1 from these two terms. From the first term, we get 2x. From the next term, we have a 5. Compare the two answers. The answers are exactly the same. Just the order of the brackets is changed. Here is 2x plus 5 times x minus 1. Here there is x minus 1 times 2x plus 5. But the order of the brackets in the multiplication doesn't matter. So the answer is the same. Maybe at first this method is a little confusing. All the methods for factoring trinomials with a leading coefficient other than 1 is confusing. But if you practice one method and only one method, gradually you learn the process and you can apply it for any question. Now look at this next example. 6x to the 2 plus 7x minus 5. The leading coefficient is other than 1. First we try to factor it, but there is no common factor between 6, 7 and negative 5. So we have to work as it is. 6 times negative 5. If you remember, the first step is always multiply that number That leading coefficient by the constant 6 times negative 5 is negative 30. Now we look for two numbers that their product is negative 30 and their sum is 7. Can you guess that numbers? Yes, those numbers that we are looking for are 10 and negative 3. 10 times negative 3 is exactly negative 30, and 10 plus negative 3 is 7. We want sum to be 7. 10 plus negative 3 is 7. So the numbers that we are looking for are 10 and negative 3. So now we are going to write this 7x as 10x minus 3x, or negative 3x plus 10x. The order is up to you. Here 6x to the 2 we have. Then you can put 10x minus 3x, or you can say negative 3x plus 10x. If we factor from these two first term a 3x, because 3x is common, then we have 2x minus 1. And if you look at these two, if you factor 5, then you have also 2x minus 1. Maybe you think, what happens if we factor these common factors from these two? What happens if these two are different? If these two are different, then this shows that during the process you made a mistake and you have to fix that mistake, because always in this technique you should get same expressions in these brackets. They are the same always. Now we factor the 2x minus 1. From the first term remains 3x, from the other term plus 5, and this is the factor form of that trinomial. As you can see, gradually by doing examples you get better and better at this technique. But please learn only one method, not different method, because you are going to confuse the steps and then you cannot do anything. Now look at this example. 3x to the 2 minus 16x plus 5. 3 times 5 is 15. So we are looking for two numbers that their product is 15 and their sum is negative 16. 3 times 5 is 15. What are the numbers that their product is 15? 1 times 15, 3 times 5, and so on. But the sum is negative, so two numbers are negative. Negative 1 times negative 15, negative 3 times negative 1, which negative 5, which one is the answer? The answer, the numbers that we are looking for are negative 1 and negative 15. So we can write this in the form of 3x to the 2 minus 1x or minus 15x. Again, the order really doesn't matter. Minus 1x minus 15x plus 5. From these two first term, we can factor x. Then we have 3x minus 1. From the next two term, we can factor a 5. But if you factor 5, let's see what happens. Then you would have negative 3x plus 1. This is similar to this, but not the same. So we can understand it's better to change 5. We have a negative 15x, so it's better to factor negative 5. If you factor negative 5, then you have 3x minus 1. Negative 5 times 3x is negative 15x. Negative 5 times negative 1 is plus 1. Now look at the brackets. They are the same. They should be the same. They are always the same. And then from the first term we have x, from the other one negative 5. This is the factor form of this expression. Look at this example. 3 times a plus b to the 2 plus 8 times a plus b plus 5. If you remember, we had questions like this before. A plus b is repeated. And when we look at this expression, it's a little confusing. If you want, you can change the name of this bracket to something new, because when you look at this is so big expression, so it's a little confusing. We prefer to change this to something simpler. So we name this bracket something. You can name it A, X, whatever you want. Here I am going to name this bracket X. I name this bracket X. If I name this X, so this expression can be written simply as 3x to the 2 plus 8x plus 5. Now forget this. Focus on this expression. We have a trinomial. Leading coefficient is 3, which we cannot factor 3 from these. So we have to use the technique that already we know. What was the technique? We multiply 3 by 5. So we are looking for two numbers that their product is 15 and their sum is 8. Those numbers are 3 and 5. 3 times 5 is 15, 3 plus 5 is 8. So we can write this as 3x to the 2. We split the middle term and we write this as 3x plus 5x plus 5. If we factor 3x from these two first terms, then we have 3x times by x plus 1. And if we factor 5, then we have x plus 1. X plus 1 is the common factor between these two expressions. We factor that, then we have 3x plus 5. This is the factored form of this expression. But is this our question? No, it was this our question. Now we remember x is a plus b, so we replace every x here. We erase this x from here and we replace it with whatever is here, a plus b. So now we have to rewrite our answer in this form. What is x? A plus b. So a plus b plus 1 times by 3 times x, so 3 times by a plus b plus 5. And this is the factored form of the original question. Now maybe you wonder, should I multiply 3 in the bracket? It's up to you. This answer is 100% right. If you multiply 3 in the bracket, it's also right. It's completely up to you to leave it in this form or you multiply 3 in the bracket. Let me show you what happens if we multiply 3 in the bracket. A plus b plus 1 times 3a plus 3b plus 5. Both of these answers are right, and it's up to you which form do you like more. Now look at these questions. We have trinomials here, but the problem is that the degree is not 2. Usually we prefer to see something like x to the 2 plus 5x plus 7, something like that. But here we have t to the 4, t to the 2. Remember, this is what we are looking for mostly. X to the 2 plus a number times x plus another constant. This constant is 2. A number is 3 here, but we don't have x and x2. We have t2 and t4. But attention, 2, 1, 4, 2. The ratio of the powers is the same. 4 over 2 is the same as 2 over 1. 2 over 1 is the same as 4 over 2. So here we understand that maybe we can change again the name of the variable to like the previous question. We can do this here. Please pay attention. This is a technique that you can learn here. T4 is basically t2 to the 2 plus 3t2 plus 2. So attention. We rewrote this in this form. Why we can do this? Because t2 to the 2 multiply the power by power, it would be the same. But what is the reason behind this idea? Because the other term is also t to the 2. Now I want to name this t to the 2, which is repeated here, t2, t2. I want to name it again something like x or a to make it like a trinomial. So here I am going to name the bracket, I'm going to name this bracket A. So I am going to name this T2 A. So this expression is now A to the 2, T2 is A, so A to the 2 plus 3A plus 2. This is a very simple trinomial, if you pay attention. And the leading coefficient is 1, so it's very easy to factor this. We don't need to multiply this 1 by 2, because if you multiply 1 by 2, it's 2. So now we are looking for two numbers that their product is 2, their sum is 2. What are those numbers? 1 and 2. So we can factor this trinomial and write this as A plus 1 times A plus 2. But what is A originally? A is T2, so the answer is T2 plus 1 times by T2 plus 2. Now let me show you another method for factoring this. This method is the same. I don't want to confuse you. I want to show you how, without doing this, without naming T2 as A, you can get same answer a little faster. Let me show you that method as well. Here we notice that this is like a trinomial. Here we suppose this as product and this as sum. We are going to put two brackets. Normally we use x as the variable, but here the variable is not x, the variable is t, and actually t2. So as usual, because I am t here, so I'm thinking this is wrong, but I'm thinking, okay, let's put t in each bracket. Then we look for two numbers that their product is 2, their sum is 3, so we say, okay, 1 and 2. But we know that t times t is t2, but we need t4. So because we need t4, so in each bracket we have to put t2, of course. So t2 in each bracket we need. So t2 here, t2 here. This answer is the same as this answer. And if you want to make sure this answer is right, multiply these two brackets by each other, you would get same answer. T2 times T2 would be T4. T2 times 2 is 2T2. 1 times T2 is T2. 2T2 plus 1 T2 would give you 3T2. 1 times 2 is 2. But the thing is that when you see something like this, you have to notice that this is like a trinomial. This is like A to the 2 plus 3A plus 2. The thing that is important is that to notice that whatever is here is raised to the 2 in this part. If here is x, in the other part we have x to the 2. If here is t2, in the other part we have t2 to the 2, which is t4. So let me ask you something. Suppose here we have x to the 3. What we have to have here? X to the 6. The degree of this should be twice of the degree of here. So if here we have t to the 5, in the other part we have to have t to the 10. Look at the next example. It's very similar. I'm not going to show you this method. Already you have learned it. Now we say, okay, this is similar. So we put T2 in each bracket. So T2 in each bracket. T2, T2. Now we look for two numbers. Their product is 4. Their sum is negative. What are the numbers that their product is 4 and the sum is negative 5? First of all, because the sum is negative, the numbers that we are looking for are both negative. Negative 1 times negative 4 or negative 2 times negative 2. The numbers that we are looking for are negative 1 and negative 4, because negative 1 times negative 4 is 4, the product is 4, and the sum is negative 5. So negative 1 and negative 4. This is the factor form of this trinomial. But if you look at the brackets, and if you are familiar with the difference of a square's identity, you can factor this a little more. You can write this as t2 minus 1 can be written as t minus 1 times t plus 1, and the other bracket is t minus 2 times t plus 2. This is based on this identity, which probably you are familiar with. a2 minus b2 is a minus b times a plus b. I use this identity to factor each of these brackets in this form. Maybe you wonder why we didn't factor these brackets here, because here we have plus. We can use this identity when we have minus. So this is the fully factored form of this trinomial given here. Now look at this example. This is a little tricky example, and you would see something similar to this maybe in calculus courses. This is a little tricky question. 5 to the 2x plus 5 to the x minus 30. First of all, we notice that this is like a trinomial. It's not a trinomial, because trinomial should be in terms of x raised to a number, but this is exponential terms here we have, but we can name it trinomial. 5 to the 2x plus 5 to the x minus 30. The thing that we notice, and we understand that this can be factored as something like x to the 2 plus a number times x plus another number, is that we notice that if the variable here is x, the other is raised to the 2. Here is x, here is x2. If you notice here we have 5 to the x, in the other part we have 5 to the 2x, exactly double of this. This is the thing that you have to notice. Now we understand that we can factor this as a normal trinomial. Let me show you. 5 to the 2x is 5 to the x to the 2 plus 5 to the x minus 30. Now I am going to name this 5 to the x a. Then we have a to the 2 plus a minus 30. Again, this middle step, naming this expression a, is not really necessary. Gradually you can skip that. But at the beginning, it's a good idea to use this technique. Now factor this trinomial. A to the 2 plus a minus 30. Look for two numbers. Their product is negative 30. Their sum is 1. What are the numbers? The number that their product is negative 30. Their sum is 1. Those numbers are 6 and negative 5. 6 and negative 5. But what is a originally? A originally is 5 to the x, so 5 to the x plus 6 times 5 to the x minus 5. This is the factored form of that expression. Let me show you how you can factor it without changing the name, without this substitution. Again, first we notice that whatever the variable here is raised to the 2. This is the thing that we notice. So we put two brackets. In each bracket normally we have to put x, but the variable here is not x. The variable is basically this expression, which is 5 to the x, and here is raised to the 2. So in each bracket we should not put x, we should put 5 to the x. This is the variable in this case. 5 to the x, 5 to the x in each bracket. Now look for two numbers that their product is negative 30. And their sum, what is coefficient here? Don't think 5 is a coefficient. No, 5 to the x is your variable. What is coefficient of 5 to the x here? 1. So we look for two numbers that their product is negative 30 and their sum is 1. Those numbers are 6 and negative 5. Similar to before, similar to here that we did the question, 6 and minus 5. The answers are the same, as you can see. Now look at this example. This is also another challenging question. Normally you don't see these questions in an elementary algebra course, but it's good to learn these for future, especially if you take advanced courses in math. First thing that we notice, this is a trinomial, but we expect to see always a number at the end, but in all the time we have x, x, x everywhere. The other thing that we noticed is that we have something as a common factor here. 2 to the x, 2 to the x, 2 to the 3x, 2 to the 2x. We have 2 to the x in all of them. So first we are going to factor 2 to the x from all of these terms. Please pay attention, this is not an easy example. So if you cannot do this question right away, it's completely fine. This is advanced example. This is not elementary example. So we factor 2 to the x. Because if you remember, usually we expect to see something like x to the 2 plus a number times x plus another number. But this is x, this is x, this is x everywhere. And we have a common factor, and that common factor is 2 to the x. Why factor only 2 to the x? Because remember, always we factor the least degree, the smallest degree. In one factor, in one term we have 2 to the 3x, in the other one 2 to the 2x plus 1, and in the last one we have 2 to the x only. So we always factor the smallest degree, 2 to the x. We know that when we factor a common factor, it means what? It means dividing. Please pay attention to this example. X to the 2 plus 4x. When you factor x from here, what happens? Basically you divide everything by x. X to the 2 divided by x is x. 4x divided by x is 4. So when you factor something, basically it's like dividing by that common factor. So here, when we factor 2 to the x, we divide everything by 2 to the x, 2 to the x, and 2 to the x. 2 to the 3x divided by 2 to the x, we have to subtract the powers. 2 to the 3x divided by 2 to the x is 2 to the 3x minus x. 3x minus x is 2x. So we get 2 to the 2x. If we divide this by 2 to the x, then same thing happens. We have 2 to the power of 2x plus 1 minus x, the power of the top minus the power of the bottom. 2x plus 1 minus x is x plus 1. 2x minus x is x. So for the middle term, we have minus 2 to the x plus 1. And finally, if we divide this by 2 to the x, 2 to the x with 2 to the x cancel, and just we have a 1 here. Please pay attention. This is not easy elementary example. This is a little challenging question. And at least it's not bad to see the solution. Now look at the middle. Look at this bracket. This is like a trinomial. But the problem is that we expect to have whatever is here raised to the 2 here. But here is x plus 1. And if we double this, we are not going to get 2x. Let me show you the previous example that here we had. 5 to the x, 5 to the 2x. The double of this power is here. Power is 1, double is 2. Power is x, its double is 2x. But here in this example, we don't have that. If you double this power, the double of this would be 2x plus 2, but here is 2x only. So we have to fix this. What is the solution for this? Let me write 2 to the x here. I'm going to write again 2 to the 2x. Let me remind you a property in powers. Always we can write 2 to the, let's say 7 as 2 to the 5 times 2 to the 2. If you add these two, you would get same thing. Now that we know this property for powers, what we can do with that 2 to the x plus 1? We can write 2 to the power of x plus 1 as 2 to the x times 2 to the 1, or just 2. So basically we can write 2 to the x plus 1 as 2 times 2 to the x. Because if we add the power to power, we would get same thing. I know finding these things is not easy, but gradually you get better and better in math by doing lots of examples. This is the only way that we can learn math. 2 to the x plus 1 is 2 times 2 to the x plus 1. Now finally we can see the pattern here. What pattern? This pattern, x to the 2 plus a number, which in this case is -2, times by x plus another number. In this case, x is this 2 to the x, which here is 2 to the x, and here is x to the 2, which is 2 to the 2x. So finally, we have 2 to the x times by, we put 2 bracket. What is our variable here? Our variable is 2 to the x. If you want, you can name this a, and then this would be a to the 2. So in each bracket, first we put 2 to the x, then we look for two numbers that their product is 1, their sum is -2. What are the numbers that their product is 1, their sum is -2? 1 times 1 is 1, but the sum is negative, so -1 times -1. Yes, so we have to put -1 in each bracket. And this is the factored form of this expression. Please watch this part of the video again and again. There are lots of things that we can learn here. It's at first, of course, confusing, but gradually you can learn these type of techniques for more advanced courses. So let me add something here. The two brackets here are the same. If you want, because this bracket is the same as this, you can combine these two and write this as 2 to the x minus 1 to the power of 2, because we know that when we have x times x, we can simply write it as x to the 2. So if you want, you can write this final answer in the form of 2 to the x times by 2 to the x minus 1 to the 2. For this part also, how from this we got to here, let me show you the substitution technique. It's not bad to go over that. So 2 to the 2x minus 2 times 2 to the x plus 1. This bracket, extra bracket around 2 to the x is not really necessary. 2 to the 2x is 2 to the x to the 2 minus 2 times 2 to the x plus 1. Here we can name this a, so we have a to the 2 minus 2a plus 1. So this is like a to the 2 minus 2a plus 1. A to the 2 minus 2a plus 1. This simple trinomial that we have at the end simply can be written, this can be written as a minus 1 times a minus 1. But what is a? A is 2 to the x. So this is 2 to the x minus 1 times 2 to the x minus 1. But gradually, you can factor expressions like this and write it in this form without doing this substitution method. But it needs, of course, practice. I hope by watching this video you have learned about factoring trinomials. We started from easy examples and gradually we moved to harder and harder examples. If you like this video, please subscribe in my channel and see you in the next videos.